All right, guys, here is your test review for Chapter 5. Remember, this is the integration portion of Chapter 5. So this is coming from your Larson book, that black, blue, and gray with the swirl on the front, okay? From page 340, I'm going to start off with number 16, okay? When we look at this integration, hopefully the first thing that catches your eye, if you have memorized that chart I gave you at the beginning, is that the exponent in the numerator is higher than the exponent in the denominator. What rule do we use? Long division, good. So when I do long division, what's in the denominator goes on the outside, and what's on the numerator goes on the inside. So when I'm doing long division, I am analyzing my first term. What would I need to multiply x by in order to get 2x squared? A 2 and an x. So I'm going to say a 2 and an x times x minus 2. Okay? When I distribute, I get 2x squared minus 4x. Remember that everything in long division works with columns. So since I am multiplying in a 2x, it needs to go above the term that also only has a single x. And then I'm going to subtract 2x squared minus 4x. Okay? A big reminder, where most people mess up on these questions, is that subtraction goes to both of them. Okay? So I have 2x squared minus a 2x, which cancels out and gives me 0. And then I have 7x minus a negative 4x. Those two negatives make a positive, and I'm really working with 7x plus 4x, which gives me, good, 11x. Okay? Bring down the negative 3, and I do the whole process all over again. So now I'm comparing how many times x goes into 11x. What do I need to multiply? 11. Good. So 11 times x minus 2. I distribute and I get 11x minus 22. Okay. 11 is just a constant, so it needs to go over the column with constants, which is where that negative 3 is. And it was just a positive 11, so I put a plus sign. Okay. Now I'm going to subtract that 11x minus 22. And again, remember that negative needs to distribute. So 11x minus 11x cancels out to 0. Negative 3 minus a negative 22. Be careful there. Two negatives make a plus, so I have negative 3 plus 22, which gives me 19. Okay? Now, what does this long division mean? I still need to integrate the answer of this division. So what I'm really working with is the integral of the answer, which is 2x plus 11. And then I have a remainder, so I need to say plus the remainder, which was 19, over what I was dividing by. So now that I have this set up, I need to do the actual integral. Feel free to split it up in any way that makes you happy, okay? So 2x and 11, I can do something as simple as a reverse power rule. A fraction requires another kind of rule. So I'm going to split the integral of 2x plus 11. And then I'm going to do the integral of 19 over x minus 2. Okay? What is the antiderivative of 2x? Good. It's reverse power rule, so I add 1 to the exponent and divide by the new exponent, which 2 divided by 2 is 1. Antiderivative of 11. Good. I'm not going to write a plus c because I'll just write it at the very end. Okay? Now, what rule do you think I'm going to need to use here? U sub. I love it. Okay? Anytime you see that denominator, u is x minus 2. What would u prime be? 1. So where should I be able to find that 1? In the numerator. Wonderful. So what is currently in that numerator? What can I do with that 19? Good. Bring them to the outside, and now I'll have a 1 there. So now I can say plus 19 times the integral of u prime over u. What kind of a rule is u prime over u? Good. So I have plus 19 ln of absolute value of u plus c. And now put that u back in. And then don't forget the other two pieces that you had solved earlier. Just drop them down. You don't have to rewrite them every time. And I am done with this question. I have finished integrating. All right, let's look at our next question. This is number 31 from that same page. It says the integral of cotangent of theta over 3 d theta. So when you see a question like this, I'm trying to throw you off with that theta over 3. Okay, anytime you see a number being divided at the bottom, you are allowed to rewrite this as the integral of cotangent of 1/3 times theta. Okay? What type of a question is it if there's an inside to the trig? Good job, guys. It's u sub. Okay? Who is my u on the trig function? 1/3 theta. The inside is the u in your u sub. What is the derivative? 1/3. So what's wrong with this problem if u prime is 1/3? Good. You need to see that 1/3 here, which means what do I have to do the outside? Good. I have to put a 3 over 1 or just a 3. Okay? So now when I go to rewrite this question, I'm going to bring that 3 down. Okay? The 1/3 turns into my u prime. And now I write cotangent of u. What is the antiderivative of cotangent of u? Good. Ln absolute value of sine of u plus c. Last step. Plug in the u. So I have 3 times ln absolute value of sine of, you can write 1/3 theta or you can write theta over 3. Okay? And then your plus c, and you are done with this question. All right, so let's look at this next question. This is number 55 on the same page. Hopefully your eyes go to the fact that there's a parentheses squared with something on the inside. Okay? So that would make this type of problem a u sub. So u is always on the inside of the parentheses. So it's 1 plus ln of x. So my u prime, what is the derivative of 1? 0. Good, and the derivative of ln of x? 1 over x. So, if I need to rewrite this, this one might be a little visually difficult to see, okay? So, watch me for a second. Do you agree that, just like in this last problem, divided by 3 is the same thing as saying times 1/3? Yes. So, in this question, divided by x could be the same as saying times 1 over x, which is going to be useful for me in this problem. Does that make sense? Yes. Okay, so I can say the integral from e to 1 of 1 plus ln of x squared times 1 over x dx. And now it's easy to spot my u prime, right? And that this is my u, and it's going to be squared. Okay? Remember that when I solve u sub and it's a definite integral with an a or a b, I need to solve for my new limits. So I need to say what my new limit would be at e if I plug it into u. So I say 1 plus ln of e, which is really 1 plus ln of e is just 1. So my new upper limit is 2. Okay? U at 1 is 1 plus ln of 1. ln of 1 is? Good. So my new lower limit is 1. Okay? So the new question that I'm writing, you're going to see this get much shorter. It's the integral. Instead of from 1 to e, it's from 1 to 2. And then this becomes u squared, and this becomes du. Okay? Antiderivative here is just reverse power rule. Good. From 2 to 1. I can leave that 1/3 on the outside and deal with it at the end. 1/3 times 2 cubed minus 1 cubed. 1/3 times 8 minus 1. Final answer is just 7/3. Oops. So for our next question, we're going on to page 360 from that same textbook. From that page, I'm going to do question 100 and 125. So looking at question 100, this is an exponential function. We've talked in the past that for exponential functions, we do work with u sub, and the u is always found in the exponent. So in this case, my u would be my exponent, which is negative x to the 4th. My u prime, or du for that, would be power rule, negative 4x cubed. Can you spot your u prime in this question? Yes, so this is a really neat, easy question, okay? Nothing is missing, nothing is extra, so I can rewrite this as the integral of e to u, and this changes into du. And of course, one of the easiest integral and derivative rules, what is the antiderivative of e to the u? Good, e to the u plus c. And what's my last step? Good, plug that u back in. So final answer is e raised to negative x to the 4th plus c. And again, this would be considered one of the easy questions on the test. All right, so our next question is on the same page. It's number 125. Very similar to the last one we just did. It is an e, an exponential. The difference is that it is a definite integral, so we are going to have to change our a and our b. Okay? So if it's exponential, who is my u? Good. We have sine of pi x. Who is my u prime? Cosine of pi x is the most common good misconception. This is a chain rule, so you have to do times derivative of the inside, which gets you that other pi on the outside. Okay? And then in a moment, we are going to change our u's. So hopefully you can see clearly that our u was picked from right here. And here we have part. Oh, I messed up in writing the question. I'm so sorry. There's supposed to be a pi in here. Do you see that we are missing something? So if I want to put a pi there, what else do I have to do? Good. 1 over pi on the outside. Okay? So as I start to rewrite, I'm going to say 1 over pi times the integral. I'm not going to write my a and my b yet because I'm going to change them. Of e raised to u, and all of this is your du. Okay? So I need to find what my new top limit is. So I'm going to plug in pi over 2. So I'm working with sine of pi squared over 2. Do you see why I wrote squared? The u had a pi in it, so pi over 2 times pi is pi squared over 2. Don't be afraid to leave it like that. I know it looks ugly. That just means we're going to be allowed to leave our answer ugly, okay? Now do the same thing for the lower limit, okay? If I plug in 0, then I'm plugging 0 into here. Sine of pi times 0 is just 0. Remember, if we have it on our unit circle, we have to finish it. And on our unit circle, sine of 0 is 0. Okay? So my lower limit is easy. It is 0. But my top limit is ugly. It's sine of pi squared over 2. Okay? Drop down your 1 over pi. What is the antiderivative of e to the u? Good. I don't need my plus c. And now I'm just going to plug in my a and b. Okay? So I bring over that 1 over pi, and I multiply it with e to sine of pi squared over 2 minus e raised to 0. Do you know something by memory to clean this first part? I don't know what sine of pi squared over 2 is, so we can leave that. How about e raised to 0? Yes, what is e raised to 0? 1. So I can say 1 over pi times e raised to sine of pi squared over 2 minus 1. And I'm going to stop there. You are fully allowed to stop there. There's nothing cleaner we can do to that. All right, so these next 3 questions I'm going to show you, I labeled them all together because they are very similar. The first one I'm going to do is on page 369, and it is number 85. Okay? Remember that when I have 2 functions separated by subtraction or addition, then I can separate them into 2 integrals. Okay? So you are free to change this to the integral from 0 to 1 of 5 to the x dx minus the integral from 0 to 1 of 3 raised to x dx. Now, I'm not saying that this is necessary. I'm just saying that it is an option in case you like seeing them split. Okay? Now, these are a number raised to a function, so these are exponential. And if we were to consider u sub, exponential functions have the u in the numerator. If we treat this as a u sub, my u would be the exponent. For both cases, it would be x. And my u prime would just be 1. Do I need to do u sub when my u is just x and my u prime is 1? No, I really don't need it. So we can say not needed. I can go straight to the exponential rule. Okay? What is the antiderivative of those exponential functions? The original function over, nice, ln of the base. So that'll be my answer for the first one. Minus the second one will be the original over ln of the base. And since they both have the same limits, you can just write it once. Okay? So I'm going to scoot on over and I'm going to say my function at b, my f of b is 5 raised to the first over ln of 5 minus 3 raised to the first over ln of 3. That's f of b, my function at b, minus my function at a, 5 raised to 0 over ln of 5 minus 3 raised to 0 over ln of 3. Okay? The biggest thing I can clean here is anything raised to 1 is itself. And then anything raised to 0 is just 1. I know you might have the urge to start distributing and combining according to common denominator. Don't waste your time. Okay? Once you're done with the calculus, you are done with the question. So this would be considered our final answer. So this next question is a little deceiving. I'm giving you the heads up because there is one like this on the test, okay? You're not used to seeing these maybe with trig functions, okay? Once you realize which rule it is, it's not a bad one, okay? So if I analyze, I know that sine and cosine are derivatives of each other. If I do use some sort of like a u sub, then the u would be the one with the bigger exponent, okay? So if sine were my u, and this would be u prime, then technically I have u prime over a number, possibly squared, is a hint, plus the function u squared, okay? So u prime over a squared plus u squared is arctangent, okay? Remember the chart we filled out for the arcs? We set up our a squared, our a, our u squared, our u, and our u prime. So a squared would be 1, and a, the square root of that, would also be 1. U squared would be sine squared. The square root of that would just be sine. And the derivative of that sine is cosine. Okay? So you can start seeing that this integral can be written with u prime over a squared plus u squared. And that's hopefully when it becomes a little more obvious that it is arctangent. That would make the antiderivative of that arctangent of u. If this was an indefinite integral, you would put your plus c and plug your u back in and you'd be done. Okay, it'd be nice and short. But because this is a definite integral and I use u substitution, I need to take a moment and change my u's accordingly. So u at pi over 2 would mean that I'm saying sine of pi over 2. What is sine of pi over 2? 1. And now I'm going to plug in 0. What is sine of 0? 0. So all I have to do now is change those limits to 0 and 1 and take this from 0 to 1. Okay? So that means I'd be saying arctangent of 1 minus arctangent of 0. Remember that this poses the question, when on my unit circle did tangent equal 1? Who can remember when tangent equals 1? Beautiful. Pi over 4 minus, and who remembers when tangent equals 0? At 0. Good. Pi over 4 minus 0 is? Pi over 4. And I am done. All right, so this next question comes from page 388, and it is number 67. Anytime you see dy dx, remember that notation means that the derivative equals this function. So if they gave you the derivative, it means they want you to work backwards and get back to the original. The way we get back to the original is by doing the antiderivative, okay? So they just want me to do the antiderivative of 10 over x times the square root of x squared minus 1. And then I place my little dx there, okay? So what type of question does this look like if I have that radical and the x down there? It is definitely one of the arcs. It is arc secant, okay? So the moment you catch it's an arc, you want to set up your a squared and your a, and then your u's. The squared, the original, and the prime. Okay? In this question, who is my a squared? Good, that makes a also 1. My u squared is x squared, which makes my x, I keep saying the answer to the question, x, and u prime would be 1. Okay? So, let's check if anything is missing. My u in the formula should just be x. That's fine. I'm not missing anything down there. And my u prime should be a 1. What do I do if I have something extra? Right, I'm allowed to take that 10 out to the front. So if I divide out a 10, now I have a 1 in the numerator. Okay? So I'm allowed to rewrite this as 10 times the integral of u prime over u times the square root of u squared minus a squared. And again, hopefully this makes life a little easier now. You can clearly see that it is an arc secant. I forgot to put my 10 over there. I'll move my 10 now. Okay. Oh, and I made another mistake. I have to do times a 1 over a. I forgot my arc secant had that. Times the absolute value of u over a plus c. Okay? So this should look like 10 times 1 over a would be 1 over 1. Okay? So do I really need to write that 1 over a if it's 1 over 1? No. So now arc secant absolute value of u, so absolute value of x over a. Absolute value of x over 1, what am I going to write? Good, absolute value of x, and then plus c. Okay? A reminder that when I have a plus c, this is called a general solution. The question like this on the test will have a part 2 that says find the particular solution for the point 3, 0. Okay? Remember that 3 is our x and 0 is my y, what I set it equal to. So at this point, I would say 10 arc secant of absolute value of, instead of x, I'm going to fill in the x, plus c equals 0. My next step is to find what c equals. So I'm going to subtract this entire portion over to the other side, and I could say c equals negative 10 arc secant of absolute value of 3. Last step to finding particular solution is to plug my c into my general solution. So I can say y equals 10 arc secant, absolute value of x, and instead of saying plus c, I'm going to plug in what c equals, which is, right, minus 10 arc secant of absolute value of 3. And now that is my particular solution. Now, so this next question is on page 41. It's number 52. Believe it or not, it was even one of your homework questions. Okay, so this one is a little trickier. Hopefully your thought process starts by e to the x. It's an exponential function. So if I am working as an exponential function, then my u is just the 2x, right? But I have way too many other e to the x's, okay? So do you agree that e to the x gives you e to the x as its derivative and integral? So that means that numerator and denominator could give you each other as their derivatives, okay? So I need to pick numerator or denominator as my u for a u sub. The next question you should be asking yourself is, if I do pick u and u prime to do a u sub, do I have a rule for u being in the numerator and u prime being in the denominator, or vice versa, u prime in the numerator and u in the denominator? I have the u prime, right? And what rule is that? ln. ln has u prime in the numerator. So that means for my u, it's going to force me to want to pick the entire denominator, okay? So e to the 2x plus e to the negative 2x. Be careful with the chain rule here, okay? One term at a time. What is the derivative of e to the 2x? Okay, don't forget your chain rule. Times derivative of the exponent is 2, okay? plus, now the second one, derivative of e to the negative 2x. Rewrite times derivative of the exponent, negative 2. I'm going to write this a little cleaner. It looks like 2e to the 2x minus 2e to the negative 2x. Compare that with what you have in your numerator. I'm missing a 2. So again, I'm just going to do some rewrites, so hopefully it helps your eyes. These 2's I could technically take out and say 2 times e to the 2x minus e to the negative 2x. And now I see what I have in my numerator, and I'm seeing that I'm missing the 2. So if I'm missing a 2 in the numerator, what do I need to put on the outside? A 1/2. Okay? And now you can go straight to the rewriting of half times the integral of, I have u prime on the top over u. So I have 1/2 times, antiderivative here is, all right, ln absolute value of u plus c, which taking one step further is just plugging my u back in. Half times ln absolute value of, my u was, beautiful, and then your plus c. And you are done with this question. So for our next question, we are on page 402. I'll take 2 questions from that page, starting with number 71. Here's our integral. Hopefully your eye catches that this is an exponential function, a number raised to a function, times something else. But anytime you see an exponential function, we remember that our u for u sub is found in the entire exponent. Okay? What is the derivative of that exponent?
2x plus 1.
Good. So if I do chain rule, I move the 2 to the front, subtract 1 from that exponent, rewrite the inside, times derivative of the inside. The derivative of the inside is just 1, so that doesn't change anything. Okay? So I spotted my u, and now I spot the majority of my u prime, but what's wrong? Good, missing a 2, so what do I put outside? Nice. Okay? So now I bring down that 1/2. Integral, I'm going to write my u prime at the end as a du, and I'm writing 5 raised to u. What is that antiderivative?
5.
Good, it's rewrite 5 to the u over ln of the base, which is ln of 5. And then you have your plus c. Okay? Don't be surprised if those are multiplied together, meaning that the 2 is combined with the ln of 5. And of course that your u is plugged back in. Okay? So I have 5 raised to x plus 1 squared over 2 times ln of 5 plus c. Okay? All right, our last question from same page 402, number 87. Whenever you see a radical in the denominator, I hope your mind goes to one of 2 thoughts. Either u sub or an arc. Okay? So if it were u sub, let's write ourselves through the thought process. My u would be 1 minus x to the 4th. And my u prime would be negative 4x cubed. Do I have a negative 4x cubed in the numerator? No. If I was just missing the 4, that'd be okay. But I'm also missing variables. I can't change that. That is why this is not a u sub. And it hopefully leads you to realize that this is an arc. Okay? So anytime you're going to start an arc, you want to set up your chart of a squared and a, u squared, u, and u prime. A squared is 1, which makes a 1. U squared is x to the fourth. What would that make U? Nice, x squared. And what would that make my U prime?
2x.
Nice. Sorry for that phone there. So, all right. So, now when I analyze, I have my a squared right here, my u squared right here, and then for my u prime, I'm missing a 2. Okay? So if I'm missing the 2, I'm going to put a 2 on top, which means that I need? Good, I need a half out front. Okay? So drop that 1/2. Okay? Integral of u prime over square root of a squared minus u squared. And which arc is this one? Nice. Arc sine, okay, of u over a plus c. Last step, plug in that u and that a. A is 1, so it's going to make that nice and easy. And u is x squared. So I have half times arc, oh, look at me forgetting my letters, sine, again, u over a, so it'll just be x squared plus c. All right, guys, that completes our review.